Welcome everyone. Today's lecture is going to be an introduction to hypothesis testing for estimating one population mean. And I think the best way to illustrate how we can estimate one population mean using this particular technique called hypothesis testing is to look at an example. Suppose the commissioner of college basketball states that the mean GPA of all college basketball players is 3.0. So whether that's true or not is something up for debate, and we'll test whether the commissioner's statement is true by collecting data. And so we have a nice visual for our problem. So in order to test whether the claim is true or not, we go out and collect a simple random sample of college basketball players. So suppose we have a simple random sample of 36 college basketball players. And from those 36 college basketball players, we obtained a sample mean GPA, X bar, of 2.0. And let's assume that we have a population standard deviation of 1.0 with a significance level known as alpha of 0.05, and we'll comment more on the role of the significance level in the context of hypothesis testing. So to recap, the commissioner has made a claim that the mean GPA of all college basketball players is 3.0, and we want to determine whether that's actually true or not. We suspect that perhaps this is not true, and in fact that the mean GPA is less than 3.0. So we go out and collect a simple random sample of size 36, obtain a sample mean GPA, right? And we have a population standard deviation. The basic setup of hypothesis testing so we have two options. Option one, we have what's called the null hypothesis, or the claim, H sub naught. The null hypothesis represents the commissioner's claim that the mean GPA is 3.0. We'll put in parentheses claim. Now we have a counterclaim. We suspect that the mean GPA is actually less than 3.0. So the alternative hypothesis is mu is less than 3.0, and I'll put in parentheses our suspicions. These are our suspicions. So at this point, we have to come up and try to make a decision. Either the claim is true, i.e. the null hypothesis is true, or the null hypothesis is false. So the two possibilities one, or A, that the null hypothesis is true. If the null hypothesis is true, or the claim is true, we're going to fail to reject the null hypothesis, fail to reject the null hypothesis. If the claim is false, or in other words, if the null hypothesis is false, then we're going to be inclined to reject the null hypothesis. So reject the null hypothesis. Okay? So whatever conclusion we make, it has to be one of these two. Either the claim is true or the claim is false. Now, the next thing we need to do is to create a nice visual for representing these statistics. So we're going to plot a sampling distribution. This is a sampling distribution of sample means for samples of size 36. So we're plotting a distribution of sample means. And these are for samples of size 36. The first thing that we do is we plot the claim at the center. We always put the claim at the center of our sampling distribution. The claim is that the mean GPA is 3.0. Now we'd like to standardize 3.0, and we know that the associated z-score for a mu of 3.0 is z is equal to 0. The next thing we need to do is we need to standardize our x bar. If you recall, our x bar was 2.0. So certainly 2.0 is going to lie around here in the left tail. So we can put x bar 2.0, but we'd like to be able to standardize 2.0. In order to do that, we need to use what's called a z-score. We have x bar minus mu divided by sigma over root n. Okay. Now, x bar is 2.0, the mean is 3.0, the standard deviation is given to be 1 in the problem, divided by root 36. If we consolidate the numbers, we have negative 1 over 1/6, or negative 6. So the associated z-score with an x bar of 2.0 is negative 6. Now let's stop to think about that for 1 second. We plotted the claim at the center of the graph, the claim that the mean GPA was 3.0, a z-score of 0, and we obtained data that yielded an x bar or a sample mean GPA of 2.0, and it turns out that this 2.0 lies 6 standard deviations away from the claim. This 2.0 lies 6 standard deviations to the left of the claim, which is pretty far. So perhaps it seems plausible that this claim is probably not true. We're putting our faith in the data. We have a nice sample size of 36. We have a simple random sample. And it seems likely that we're going to reject the claim or reject the null hypothesis in favor of the alternative hypothesis. To finalize the problem, we need to calculate the probability of obtaining an x bar of 2.0 or less than 2.0 given that the claim is true. The probability that x bar of obtaining an x bar of 2.0 or less than that is represented by this shaded region on the graph. This is going to be called a p-value. So we need to find or calculate the p-value. Now, to do that, we need to use technology like a graphing calculator or Microsoft Excel, SAS, SPSS. There are many ways of calculating a p-value. For now, we're going to give you the p-value, and then in another lecture, we'll show you how to calculate p-values. The p-value in this case, not surprisingly, is something very close to 0. Remember, this area on the graph doesn't represent much. So it turns out that the p-value is very close to 0. What this means is that it's highly unlikely that we would have obtained a sample mean of 2.0 or less than 2.0, assuming that this claim is true. So we are inclined to reject the commissioner's claim. Now, there's a hard and fast rule for determining whether we reject or fail to reject a claim. And this is where the significance level comes into play. So what we do is, so the rule is we compare the p-value to alpha, the significance level. And the rule is, if p is less than or equal to alpha, we reject the null hypothesis. If the p-value is greater than alpha, we fail to reject the null hypothesis. Okay? If we obtain a very small p-value, in other words, p is less than or equal to alpha, a very small p-value indicates that our sample mean lies far away from the center or from the claim. If we obtain a large p-value, in other words, p is greater than alpha, that means that we have an x-bar or a sample mean that lies close to the center or close to the claim. In this particular case, in our case, here, p is roughly 0, and our alpha, stated at the beginning of the problem, is 0.05. And certainly p is less than or equal to alpha. 0 is less than or equal to 0.05. Therefore, the conclusion is we reject the commissioner's claim claim, which is the null hypothesis, and we're in favor, so we support the alternative hypothesis, and if you recall the set of hypotheses, we had a null hypothesis of mu of 3.0, an alternative hypothesis of mu less than 3.0. So our data indicate that the null hypothesis is not true, so we reject the null hypothesis in favor of the alternative hypothesis, concluding that the mean GPA of all college basketball players is indeed less than 3.0 with a significance level of 0.05. And that will conclude our introduction to hypothesis testing.